Welcome to this part 4 of the videos focusing on logic, Boolean logic, truth tables and logic gates. Last episode, episode 3, we looked at logic gates in series. Now we're going to look at them in parallel. Let's have a look at what that means. Well, on the screen we can see that I've got 3 logic gates. I've got a NOT gate, here it is, an AND gate, and I've got another AND gate. What I want to do is join those together. So first thing I'm going to do is attach my light bulb. There we go. And of course nothing happening with the light bulb yet because nothing is joined up. Okay, so let's move that over so I've got a little bit of space. Let's join our inputs. Let's turn all of our inputs to high or on to begin with. There we are. So our NOT gate's got an input, our AND gate's got 2 inputs, and they're going to join to the inputs on the end there. Now, if we look at the screen, nothing is happening with the light bulb. And that is because, of course, we've got 3 inputs, all 1 or all on. Now, the input of 1 to a NOT gate will produce an output of 0, of course. Now, we've got 2 inputs of 1 to the AND gate, so that will produce an output of 1. So those outputs become our inputs to the logic gate, the AND gate that is in series after the 2 in parallel. And of course, if we look at that, we've got a 0 as an input, a 1 as an input, and if you do that to an AND gate, you won't produce an output, or the output that you produce will be 0. Okay, so let's move these out of the way for the moment, and let's change our values. Let's remove the 1 input to the NOT gate and make that a 0. Now immediately we can see that our output is now on, or our output is 1. If we look at this, well, we've got a 0 as the input to our NOT gate, so that becomes a value of 1 as an output because it inverts from a NOT gate, and our 2 inputs to the AND gate are 1, of course, so that provides us with 2 1s to our AND gate in series, which produces that output there. Now let's see what happens when we remove one of the positive inputs to the AND gate and then make that a 0. Well, we can see that now the light bulb is off. And the light bulb is off, of course, because, well, we haven't changed the NOT gate, so the output is still 1, but we've changed the AND gate. One of our inputs is 0, one of our inputs is 1, and that on an AND gate always produces an output of 0. And of course, those are feeding into that second AND gate, so we need to remove that and move that over there, so that gives us that. So we've just looked at logic gates in parallel using an AND gate, a NOT gate, feeding into an AND gate. So let's have a look at a slightly different configuration. Let's just remove these. There we go. And let's work with an OR gate, an AND gate, and another AND gate. So here we are. So we're going to feed inputs to all of our gates, and being consistent, I'm going to switch all of my inputs to 1 or on to begin with. There we are. So okay, and I need another one there. There we go. So right, so that feeds into there. Now that feeds into our AND gate at the end there, and we need an output, so we're going to use the light bulb. And of course the light bulb is on. The light bulb is on because we've got all of our inputs are on. So if all of our inputs are on, then that will produce outputs of 1. Those outputs of 1 become the inputs to that second AND gate, which produces that output there. Okay, so let's change things about a bit. Let's swap one of the inputs to the OR gate from a 1 to a 0. Okay, no change. Now, no change, of course, because if we're working with an OR gate, either of the inputs can be on to produce a output of 1. And of course, we haven't changed the inputs to the AND gate, so that remains 1 anyway. So there we go. And we can test that hypothesis out by just moving things around. So I'm just going to remove that. If I push that one up there, so that becomes the A input, if you like, to our OR gate. And again, nothing happens. Now, let's remove this completely and put 2, 0 or off inputs to our OR gate, and of course our light bulb immediately is off. Now let's double check that, just move that there, and so there we go. Light bulb on, or output on, just remove that, make that a 0, output off, because of course our output from the OR gate is 0. We haven't changed the AND gate, so that's still a 1. Those are feeding into there, so of course that will then produce that. Now let's be very thorough in our testing. Let's remove that input there and make that a 0. Now should be no change, of course, because the output to our AND gate is 0. That becomes the input there, so we've got that. And of course if we remove that one excuse me, that one, and make that a 0, then everything of course should be a 0, which is what that is there. Okay, so we've now looked at an OR gate and an AND gate in parallel feeding into an AND gate. Right, okay, so let's take it up a stage further. Let's work with just looking for my gates here. My XOR gate and my OR gate. So I've got an XOR gate and OR gate feeding into an AND gate. Well, let's see what we can do with this. So let's have an output. Let's have our output as the bulb, and of course nothing happening yet. I will join our inputs to the AND gate. There we go. Now let's put some values to this. Let's switch all of our inputs to 1 to begin with. There we go. There we are. Oh, running out of space on the screen here for this. Just going to move that across a little bit. There we are. Okay, now all of our inputs are 1, but our output is off. It's off because of course it's not lit up, so that's a 0. Now let's see why this might be. Well, if we're feeding into an OR gate 1 and 1, 1 or both ones, then the output will be 1. However, remember we're working with an XOR gate up here. We're working with an XOR gate if both of the inputs are positive, or both of the inputs are the same, then the output has to be 0. And because we're feeding into the AND gate, we're feeding a 0 and 1 into the AND gate, it's not going to work, of course. So let's test that hypothesis by changing the value of the input to the XOR gate to 0. There we go, and immediately we can see that actually our output is set to 1. And let's refresh ourselves as to why this is. Well, XOR gates work on the basis that if either of the inputs is 1, or either of the inputs is 0, then the output will be 1. Okay, so there we go. So that feeds into that becomes a positive. And of course our OR gate hasn't changed. Both of the inputs are on, so that feeds into that. Now let's test our OR gate. Let's move that out of the way and switch that to there. And of course the light bulb is still on because either of the inputs to the OR gate are on, then the OR gate will work. So what I'm going to do is I'm going to make the input to the OR gate 0. And of course our light bulb is off because the output to the OR gate now becomes 0. Okay, now let's test our hypothesis just a little more. Switch all of the inputs off, and of course the light bulb is 0 because, remember, with an XOR gate, if both of the inputs are 0, or both of the inputs are 1, but in this case 0, then the output will be 0. Okay, so we've now worked with an XOR gate, an OR gate, and an AND gate. Alright, so one final example for us